Right. So there we go.
Okay. Hello, everyone. I want to present you my the last update of my project. As I said in the midterm meeting, we are going to focus on these following 4 faults: the Rocabreturo fault, Magno-Novellino, Acergy, and Vado di Corno. We started with Rocabreturo fault, and then we continue with others. And I want to mention that pay attention to the direction of Rocabreturo fault, because in the rest of the slides I rotate it to have a better view. So just pay attention to the NWE SE direction of the fault. And again, as I said in the midterm meeting, we are for quantifying the maturity, we are going to use the 2 observations, segmentation and damage zone. And the damage zone is the part that I am going to do with UNIP University in my secondment. So now we focus on the segmentation. For segmentation, we need the accurate mapping of the fault, the paleoseismological data, and defining the cumulative displacement of the fault. So we started with accurate mapping based on the DEM playhead, DEM LiDAR, and orthophoto. Here you can see the orthophoto of our study area, with a limited area that we have a LiDAR DEM of them. That which covers a large part of the fault trace. And here you can see the fault trace mapping of the Rocabreturo fault, and with triangular and trapezoidal facets as a very important morphological features that I explain about that in the other slide. And the yellow circle that show the places that we have a 36 coloring sampling, and the yellow rectangle that show the paleoseismological trenches that we have. Based on this data, we know that in southeastern part of the Rocabreturo fault we have a slip rate more than the northwestern part of that. If you look at the fault trace, you can see that we have a normal fault with deep direction toward the southwest, but in this part we have a fault with deep direction toward the northeast, and this is the antithetic fault for in this area. And this is the part that that was selected for opening a paleoseismological trenches in a very near future. If you look at the fault trace, we can see in the southeastern part the deformation is localized, and we have a less complexity. But if we continue toward the NW, we can see the more complexity and the increasing in the width of the fault damage zone. Based on this data, we can interpret that in the southeastern part of the fault we have a more mature part, and in northwestern part we have a immature part, less maturity. But to become sure that the other parameter didn't affect this distribution of the fault trace, we prepared at first we prepared a simplified geological map of Rocabreturo region based on 100,000 geological map that covered our study area. As you can see, the fault located in the contact of Jurassic Cretaceous limestone and Quaternary deposits. As I said, to define the effect of lithology, fractured characteristic, and bedding deep direction and bedding deep direction of geological units. We prepared a very detailed geological map. In the southeastern part, we have a massive crystalline limestone. In the central part, we have a thick layer crystalline limestone, and in the northwestern part, we have an alternation of limestone and mud. Maybe this alternation can affect this distribution. And if we look at the and we have a fault. We have a fault with a deep direction in southeastern part. We have fault with a deep direction opposite of the bedding, and and if we continue toward NW, we have a fault and bedding perpendicular to each other, and then they are parallel to each other in this part. So maybe this geometry can affect this distribution too, but this is just based on the data that we extract from the geological map. So the more data, more field survey is necessary, that we became sure about this affected. And as I said, as a third observation, we need to calculating the cumulative displacement of the fault. And so we focus on the facets. And we know that the facet is the facet can keep the cumulative displacement over a large frame, over a large time frame, and than the other geomorphological features. So we focus on that, and we have the good distribution of facets along the strike of the fault. So you can see that in the sweat profile, you can see in the southeastern part we have the height of the height of a facet is more than the northwestern part, and so it can show that the displacement is the displacement is more here is more than the other parts. But how is the deformation distributed between them is in progress, and we are working on that, and to determine how the displacement distributed between these facets. But what we can have now is that here the height of the facet is more than this part. And the other observation that we used was the vertical through along the strike. So we selected 9 places that we have an obvious scarp, and with a profile, we determined the vertical through. As this is manual, and I'm preparing a code in MATLAB to calculate it by code. But now with this calculating, we can see that again this is a map view. And we can see that again in the in the southeastern part, we have a more displacement than the northwestern part, and we can see the decreasing trend of cumulative displacement on the scarp toward the NW, same as what we can see in the facets. And there is some interesting area with very special morphological features. For example, the big gully with a deep subcision, and the smaller scale fault trace with a smaller scale facet, a smaller scale drainage, and we focus on this part and we know that this is this part is located between the less complexity part of the fault and more complexity part of the fault. So maybe it can be a transition zone or relay ramp that connected these two parts of the fault together. And just this, thank you for your attention.
Thank you, Meghalek. Okay, questions? Anybody? Yeah, Menandrin, is that an upload or?
I'm clapping.
Not raising your hand. Any questions on Irene?
For suggestion?
Yeah. Okay, just wondering, I mean, you mentioned that the displacement seems to, you know, decay somewhat when you go more to the north.
Mm-hmm.
The cumulative displacement across, I mean, the whole, yeah, the whole, you know, width of the fault zone don't seem to vary that much. It's only that, you know, it's distributed. Is that right?
Can you repeat your question? Sorry.
I mean, if you look at a more complex zone more to the north, I mean,
Yeah, here.
yeah, I mean the displacement or I mean the height of the facets, I mean, seems to be, you know, the same when you turn over.
Yes. Yes, we are calculating that. Here is a little higher than this part. Maybe we believe that maybe it's distributed between the facets in this part if you look at them. But here is concentrated, and it is some features that guide us to find which part is more mature than the other part. Because in the mature part, with the displacement is concentrated, is localized, and in the immature part is separate. So maybe we are working on that and to calculating the distribution of the cumulative displacement between them.
And okay, so I'm not a structural geologist at all, but I mean the fact that there is an antithetic fault,
Yeah.
You know,
Here.
The start of your more complex zone, is that, you know, what is the chicken and what's the egg in that story? I mean, does that make sense, my question? Or, you know, is it more complex because there is an antithetic fault, or is it?
Yes, it can be a result for that, but you know, we believe that the fault, the distribution of the fault usually is in the direction, the direction of the direction of distribution of the fault is from the mature part toward the immature part. For example, so in this case, the distribution of the fault propagation is toward the NW. So usually in the immature part, the fault present the more complexity. And for this antithetic fault, that can be a part of this more complexity. They are can affect each other, both of them. It's two sides.
Okay, so Menandrin first, and Marco then.
I think Marco was first.
Oh, I don't know. So sorry.
It's fine. You go, Menandrin, and then we'll ask. My question is very simple, actually. So
I think mine also. So on these antithetic faults, is that also normal motion, or could you have different faulting mechanisms on those?
Yes, it's normal.
okay, mine is even simpler. If I understood correctly, the trace or the section for where you are planning to do paleoseismological trenching is the only one without triangular or trapezoidal facets, right?
Yeah.
Is there a reason for that, or is just a coincidence?
No, it's not the reason. Just we selected that just because it's antithetic, and This is the places that we don't have any data for the seismic history. So we selected that just because of that.
Thank you.
You're welcome.
So the trenching is going to take place soon, or?
Yes, after Sicily, maybe at the beginning of the July. Yeah.
Yeah, it's better than in winter for sure.
June. I'm sorry, at the beginning of June. Yeah.
All right. Any more questions for Nairi?
Yeah, can I do one more?
Yeah, sure.
Can you show the profiles again where you measured the cumulative fault depth? Thanks. To what extent are you, so I'm looking at the profiles on the right, how sensitive is your measurement with respect to where you start measuring that slope?
Yeah,
I told you. Top point.
Yes, this is just manually that, and we try to follow a theory that the paper that we have in this method, but just we try to match the line for hanging wall and footwall, and then the fault, the scarps that we have, and then we can calculate this displacement. But it's I told you that it's manually, and I'm preparing a code in MATLAB that then we can calculate them automatically.
And do you assume a certain fault dip in this calculation?
The fault dip?
Yes, because right now I don't quite understand why you have a green line that goes vertically down rather than something that goes along a fault.
The blue one is the fault before eroding. You know, so now we can calculate the displacement. The vertical through, actually, the vertical through.
Okay, thank you.
You're welcome.
Nice update, cool presentation, thanks.
You're welcome.
Indeed. Okay, thanks again, Nairi. So it's yeah, Elizabeth, I think it's your turn now.
Can you see my screen?
Yes, we can.
Is it in presentation mode?
Perfect.
Okay, great. My topic is, as you all already know, flow to friction transition and carbonate rocks. But I made a little recap slide for, so everyone's on the same page. My main objective is to determine the depth extent of the seismogenic zone and also link that to microphysical process that control the deep transition from seismic to aseismic slip. And the questions that I'm trying to answer is under which condition does the deformation mode change, and also what deformation, what is the dominant deformation mechanism that controls this transition. So as you know, I'm doing experiments, and to answer these questions that I just mentioned. And today I'm gonna focus on the hydrothermal rotary shear apparatus, where I did experiments, velocity stepping experiments, to obtain the rate and state friction parameters. And in the end, I will briefly touch on a problem that we encountered when we wanted to observe some microstructures. So this is a slide that I already presented in the midterm meeting, but I decided to show it again since we didn't have time to discuss it. Those are 4 experiments that my supervisor and I did. on Solnhofen limestone, meaning that he did, Andre did the ones on the solid rings, and I did the ones on the gouge under the same conditions. And what we found out is that both solid rings and gouge exhibit velocity weakening behavior at 500 degrees, but at 600 degrees, both exhibited velocity strengthening behavior. And I'm going to talk again in a second what implication that has. Here I have a slide with my experimental plan, and I marked the experiments that I already did in green. And I divided them in velocity stepping experiments and constant velocity experiments. The velocity stepping experiments are for obtaining the strength of the material and the frictional parameters. And I just did two, but I also want to do more constant velocity experiments, because in that case I have isolated a specific temperature and velocity and can link certain microstructural, microphysical processes just to that conditions. Here are 6 of my experiments, which are all which I did with the same velocity protocol, ranging from nanoseconds to micrometers to from nanometers per second to micrometers per second at different temperatures. And I already indicated the behavior with the red annotations. But I wanted to talk a little bit more about these two, namely the one at 400 degrees and the one at 500 degrees, because they show a very similar mean shear stress, but very different patterns, meaning that the one at 400 degrees exhibits these very prominent high amplitude stick slips. And as I just said, I am gonna briefly talk about how I obtained the rate and state friction parameters, the A minus B value, and I just said it with the rate and state friction law, which is at the bottom of the slide. So for the one at 500 degrees, it's fairly simple. Under or after a sudden change in velocity and after a characteristic slip distance marked as dc, the friction is evolving to a new steady state. But if we now look at the data of 400 degrees, the stick slips, I calculated the mean shear stress with a moving window average, and then obtained the A minus B value with the same procedure. So these are my results at the moment, the A minus B values. And as you might see, it's not a very simple correlation that we can make. So there are a lot of processes going on, must be going on. But what we can see at some points that there's a negative correlation between A minus B values and temperature. And at some points that there's a positive correlation with A minus B values with velocities. So this is some work that is not finished, but I still wanted to mention it because I would be happy to hear some ideas and suggestions. I calculate the A minus B values from the mechanical data, but since we have stick slips, the dolomite gouge exhibits stick slips at some temperatures, we also wanted to calculate the A minus B values from the stick slips. Therefore, I'm for a certain velocity calculating the stress drop and the frequency or reoccurrence time. And also what we are doing is that there are some ultrasonic sensors now in the apparatus, which I run on trigger mode. So if a stick slip occurs, I sometimes can record ultrasonic acoustic emissions. But yeah, it's ongoing work. So this is the same plot that I just showed, but now I want you to look at something different, namely the gray vertical and horizontal lines. When you look at the horizontal line, you might see that the stick slips or fluctuations start at around the same displacement. So we think that something is going on there, but we don't know what. And also the massive drop in shear stress in the initial sliding, during the initial sliding. And we don't really have an answer to that. And we have a few hypotheses that we want to test. But, and I also wrote them down, but now I'm thinking maybe it's a good way to start our discussion. So if you have some ideas, maybe we can come back to this slide. And just to show that this is not an effect of our apparatus or something that I can just measure once. This data is reproducible as far as I could, I mean, as long as I did the experiments. But I also brought some data of calcite, salt, and quartz as reference. This is also shear stress versus displacement. And you can see also in calcite and in salt that it's also exhibiting this drop in shear stress, while when you look at the quartz data, it's more stable. And the problem that we encountered when we wanted to observe the microstructures is I want to extract the sample after the experiments, but sometimes it is so non-cohesive that it's looking like the gouge that I put in. So it's very hard to do thin sections. And it gets better with higher temperature and faster sliding velocity. But I'm also interested in the low temperature ones and slow ones. So what we now come up with is to use some hairspray, which is working just fine, but there's still some problems. We have another epoxy, but yeah, I just think that's a funny thing, and I just wanted to show that it's not always rainbows and butterflies in the lab, but we have to come up with some ideas. That's from my side.
Thanks. I like the product placement business at the end.
Yeah, I'm not getting paid.
Yeah, Mike, you have a question? Oh, no, you are uploading. And I'm sorry, it's confusing for me. I have a quick one, or I don't know if it's a quick question, but how do you go actually from, I mean, you can get the stress drop directly from your stress measurements, but how do you get from there to the rate and set parameters?
We found the correlation that if you plot a stress drop versus velocities. So this is the stress drop for a certain sliding velocity. And if we plot that in a linear log plot, then the slope is the A minus B value.
Yeah.
This is what
Right. Okay. It's okay. I guess it comes directly from the model. Yeah, okay.
Yeah.
Yeah. Elizabeth, nice work. Ciao, I'm Giulio.
Ciao.
Yeah, I have several questions. Actually, I'm very curious about your results because The first thing, okay, maybe we can discuss later about the kind of epoxy to use. Very low viscosity, probably you need stuff like that. Maybe we can have a chat later, or with the people I work with in Rome or here.
Yeah.
That they have time to do science, not me. I have several questions. This is, you're showing here, of course, there is a sort of velocity dependence, clearly, in the 400 Celsius experiment. Okay, clearly, because the stick slip is, the average value is going back and forth with the slip rate.
Yeah.
So clearly, So you have a slip weakening behavior at the beginning, if you just focus on the blue one, and then the stick slip behavior. Then there is a change in slip rate when you trigger the stick slip when you decrease the velocity, which makes sense. Yeah. Okay. No, I'm just trying to follow this picture because it's quite reasonable, interesting.
Yeah.
I have two questions. One is why your Carrara marble should be white and is gray. Okay, I think you start with a marble which is white.
It's the dolomite. It's the dolomite actually.
Okay, so it's
from
not
Italy.
Carrara marble.
No, this is.
Gauge is written there. You're right. Okay, sorry, that was confusing. The second one is the fact, and that is very unstable at 400 Celsius, and so that's a bit of. I mean, I was wondering in the real world, you are in amphibolytic phases between green schist and amphibolytic phases, where you have beautiful malonites in real world, in both rocks, in both calcite marbles and dolomitic marbles. So how we can put these two things together? You understand what I mean?
I'm not
In
sure.
real world, we have evidence of dynamic recrystallization, crystal plasticity. And also, perhaps, I don't know why, is if I think at the Pagani Alps, where the Carrara marbles are calcite, but also the dolomitic marbles that are there, and they are in amphibolytic phases or green schist. That means that the temperature is 400 Celsius.
Okay.
So do you think it's because the strain rates are much lower than the one you're working on? Or maybe it is something we needed to think about.
Yeah, I definitely have to think about that.
Yeah, that's what I think. I don't know if you have some thought about that, because also in the previous slide, I think they were showing something like A minus B negative at 500 Celsius, and in the very beginning, the very beginning, I think was before
Which one?
The one before.
The one before probably was the one before.
This one.
This is a limestone, so this is calcite.
Yeah.
And I mean, this is what I've seen in the field. I mean, the Pagani Alps, we should go there, if you've never been there, but there are beautiful malonites at 400, 450 Celsius. While here, A minus B is negative. So this material should be prone to, based on the stiffness of the wall rocks, to produce earthquakes. So that's something to think about. I mean, that's if you don't have a good explanation. I was expecting to have A minus B positive. Yeah, I think also Verberne found something similar many years ago, but the geological implication of these something I would like to understand.
Yeah, I agree. I definitely have to think about that.
I mean, the experiment are showing this, so there's something we have to put the two things together. So why? What is? I don't know. Yeah. Okay, I put a note about the epoxy thing. I wrote down. Yeah. No. So thank you very much for the data. Really interesting.
Thank you, Giulio.
No, really. Yeah, I'm just puzzling me a lot. Yeah. Okay.
Bruno, you have a question? Yeah.
Yes, just a quick question. Thanks, Elizabeth. No, I'm just curious if you are planning to use different samples from gauge samples from faults that are studied also in other PhD project. Like I know that NIRA, for example, will work on some fault gauges. So I don't know if you are planning to use different samples from other faults or other similar but different lithologies.
Yeah, actually, we did plan to do that, but we haven't discussed this lately. I wanted to join Giulio on his field work and hope to find some samples there. So this is simulated gouge, but it's from real material, so it's not like just the dolomite, but it's a dolostone that I crushed. So yeah, we did plan to also use some other samples, but haven't discussed that in great detail yet.
Okay. I think it's interesting and it's important to connect all the project because some will collect maybe data in field, some others will work on modeling with some faults, but needs this kind of input data. So it's important to discuss together if you want to come back on some faults, on some areas. And okay, thanks.
Thank you.
Okay, so we're running late, so maybe we should go on. Yeah, I would be keen to ask more questions at some stage, Elizabeth. I'm surprised by the fact that your A and B parameters, I mean, depend so strongly on velocity, and I thought that right and set modeling was supposed to account for all the velocity dependence through A and B. So I don't know. Okay. Maybe I missed something, or it's just measurement errors, or I don't know. But I mean, I'm sure you will show that again. I mean, your experiments results at some stage, and we discuss that. But
Yeah.
so let's go on and start the lecture. So Marco again has been very kind to provide us with a new presentation, a new lecture with some fancy tools, apparently.
Well, let's see if it is the presentation, if the tools are actually fancy.
Okay. So the stage is yours, Marco. Go ahead.
Okay, thanks a lot. Thanks a lot, David. Okay, let me share my screen and then put it in presentation mode. Okay, and hope you can see my slides. And excellent. So, as you have seen from the emails that David sent, the title of my presentation is on public outreach and disseminating science. As you well know, I'm not actually, my expertise is not in communication. It's for the most part on modeling seismic hazard, but I took this as a sort of challenge, despite the limited amount of time that I have in this period. I'm actually currently running in parallel a training here in Pavia with 30 persons. So preparing everything had been quite challenging. Let's see if what I've been able to put together, it's in any case useful and interesting for you. So what I'm going to discuss in my presentation is split essentially in 3 parts. In a first part, I will focus on discussing briefly the role of communication, dissemination, and exploitation within the European projects, and with a focus on what we are supposed to do within threads. That's actually, I've been rereading the proposal and I've been actually discovering things that I did not catch as clearly when we were preparing it, particularly regarding the role and the importance of communication, dissemination, and exploitation. And then in the second part, I will discuss briefly about the communication of earthquake science in peacetime and during earthquake sequences, with the last part on uncertainty, because I think communicating uncertainty is particularly important in our case, given the challenge that we have in modeling a process that is so complex like an earthquake. And as you saw in the email that I sent this morning, in parallel, we'll use a tool from time to time during the presentation that is called Mentimeter. With that tool, I will propose you some polls at the beginning, at the end, and very briefly in the middle of the presentation. And for the beginning and the end, is actually interesting to understand if the presentation had been able to change a little bit your the way in which you value communication, dissemination, exploitation. And in the middle of the presentation, the goal is indeed to follow the same exercise that has been carried out in one of the papers that I've been considering while preparing the presentation, in particular regarding the way in which the risk is perceived by slightly changing the way in which a certain risk is actually communicated. But you will see that a bit better later on. I hope you are all able to access this page right now, and indeed I invite you now to go there, and we take the first questionnaire there. So do you know the difference between communication, dissemination, and exploitation? So we are 16, if I'm correct, in our, no, it's not here. This. Only 5 votes. Okay.
I mean, your question is not straightforward, you know, it takes time to think about it.
Okay. Well, maybe at the end, since at the end I will have this question again. Let's see if at the end it will be clearer in the way, let's say, what to answer. I don't see additional contributions. Maybe I move to the next question. So if you know it, or if you have a slight idea about that, what's the importance of communication, dissemination, and exploitation in our project? Okay, that's actually quite encouraging, because we are already, say, recognizing the importance of, okay, there's one that says low, okay, of communication, dissemination, and exploitation.
But then, I mean, Marco, since the 3 are different, you know, we could provide 3 different answers.
Of course, of course. Okay, but I would say that on average, we are already recognizing the importance. It might be actually interesting to see what's the balance between the 3 that we think. And if we, instead of thinking about threat in general, but if you think about your PhD, is also in that case communication, dissemination, exploitation important or less than in the project in general? Okay, maybe for your PhD, you think that it's probably a bit more important to focus on your research But of course, making sure that then the research is recognized is probably also another point that must be considered carefully. Okay, so now I go back to my presentation and I will start to discuss the first part. So what's the impact on your projects and the role of communication, dissemination, exploitation? The impacts of European projects, this is actually a schematic that I took from a presentation that was available on a website of the European Union, is subdivided in three main areas. The so-called scientific impact, the one that most probably we are more well aware of, the societal impact, and the economic impact. So the scientific impact, I think it's all clear to you. Creating high quality new knowledge, good research, publishing a lot is what is related with the scientific impact. The societal impact instead is trying to, for example, address EU policy priorities, global challenges through research and innovation. And more in general, I would say making sure that our research is able to change in some way our life, of course, in a positive manner. The economic impact is less broad, I would say, than the societal impact. And it's more related to the capability of our research of promoting new activities, of, for example, supporting the development of new products, which might not be exactly the case in terms of thread. But in our case, for example, one example of economic impact would be to find a way to port our results up until products that are used in the industry. One industry with which, for example, again, we work quite closely is the insurance sector, but it could be, for example, the engineering sector, because we came up with a way of characterizing earthquake sources that is allowing us to develop more detailed seismic hazard models whose results are used later on for designing buildings. And so every area here, in order to, let's say, maximize the impact, requires a way to communicate and distribute those results. And this is where it comes the part related with communication, dissemination, and exploitation. So communication is for the most part, focused on citizens, on stakeholders, and the media. And the way in which you must, let's say, implement a communication, a well-efficient communication strategy is to have, of course, an initial strategy to do that, to convey clear messages, and to use a variety of channels. Could be social media, could be blogs. There are various ways, and we have indeed, as you will see later on, different plans included in our initial proposal. This is again another schematic taken from a presentation from the European Union. When they are suggesting to do that, the sooner you start, the better. But clearly, in order to start disseminating, you need to have some results. So I don't think that we are right now at the stage of being able to communicate extensively with the public. And why? Of course, it's also partly obvious from the previous slide, because it's one of the goals, but it's also very important to make sure that we are able to transfer our knowledge to a variety of stakeholders, including the public. And in the case of earthquakes, is also a way to raise awareness and to make sure that citizens are aware of the risk that in some cases they are exposed to. Dissemination is more instead focused on making sure that the science that we produced is communicated and used ideally by various groups of stakeholders, including other scientists, the industry, various authorities, policymakers. For example, if we develop a wonderful seismic hazard model, we want to make sure that that model or components of that model are used for national seismic hazard analysis, and later on, ideally, also for updating the building codes. So there are very many different ways in which indeed it's possible to implement a dissemination strategy. And again, when the sooner is always the better, but that has to be compatible with the development of the process. And why? Well, from a purely scientific point of view, of course, communicating results and communicating research is important in order to get scientific endorsement, scientific approval, scientific recognition for our results, but also to contribute to maybe additional research that will be carried out at the end of our project. Exploitation is instead an activity that is a bit more practical and is focused, for example, on making sure that the research that is produced, the tools, the results, the data sets are made available to, again, variety of potential interested users. And that can be done, for example, by disseminating software or sharing results through ad hoc websites. That's also an activity that's been started. In our case, for example, at GEM, we do that regularly because in particular, when we develop code, we publish that on GitHub. But again, there's a number of strategies that can be put in place in order to make sure that exploitation is implemented at the maximum of their possibilities within a project. In TRED, we have just to recognize how important is to communicate, disseminate, and exploit results. In TRED, we have a dedicated work package, which is work package 5, that is titled Communication, Dissemination, and Exploitation of Results. This work package is led, actually, I think I thought I fixed this. There is still a list, but in reality, is Maria Ortuño who's coordinating this work package. And the objective of this work package is to coordinate the communication dissemination actions. There are, of course, a variety. In theory, all the partners, all the organizations involved should contribute to the activities related to communication, dissemination, and exploitations. And there are a number of deliverables. Some of them that are more general related to the project, but you might also see that there is a deliverable that is supposed to report on the outreach activities that are carried out by the doctoral candidates. This is also something important. It's of course something due very late in the project, but we need to make sure that throughout the duration of your PhD, we will organize and carry out a number of outreach activities. Some ideas, some notes taken again from the proposal regarding dissemination in this case, and some of the things that were considered. So cooperation with the outreach offices in the universities, in the organizations in which you are carrying out your PhD, of course, contributing to social media, and making sure that there's an involvement of the equal opportunity point and in order to emphasize the research that they are carried out by females. But I mean, if it's good research, I don't care at all if it's male or female. I'm just happy to recognize the good work that is done. And indeed, today we had two females presenting with very good stuff. The YouTube channel, of course, it's another important activity. But there are also other activities that I don't know the extent to which so far have been organized or maybe even just planned, such as, for example, try to have contacts with high school students and participate to open days at the universities. I think that for the one of you that are working within universities, that will be probably easier. For the people that are working, for example, at GEM, where we don't have these events in which we are inviting public or just disseminating the science dissemination events, it will be a bit more challenging. And I also discovered that I am your industrial liaison because of the experience that at GEM we have in, let's say, porting science into application in the insurance sector, but also in the engineering sector. Okay. And of course, for the extent possible, I will be happy to help you with this part, especially when you will get closer to the conclusion of your project. Still related to that, regarding the dissemination, of course, publication of your research in peer-reviewed journals is quite important. In the proposal, it's expected that every doctoral candidate will publish something in the range of 2-3 scientific papers. Participating to international conferences is also very important. In addition, I saw that we had this, which I found quite particularly interesting. So the possibility or the idea of organizing an event in collaboration with the OECD on earthquake science and society. Of course, this is also, oh, sorry, why is 2024? Maybe this is something not completely correct that I took from, it's in the proposal, but probably the year is not the one in which we want to organize the workshop and training schools. That's ongoing, and I think that so far has been quite interesting. And of course, the TREAD website that is maintained by Innovacta. But also posts can be quite interesting to have, particularly on dedicated website like Piloseismicity or the EGU Tectonics division, with which I'm not so familiar as Piloseismicity. And of course, particularly for the part on exploitation, is important to set up open access data hubs, because they will help in improving and exchanging and make quicker the exchange of information and the dissemination and the use of that information by other people. These are additional activities, probably not so important to go in detail to each one of them, but you can see in particular the results and the target. So scientific production, lectures and trainings, which is what we are doing right now. Uncertainty on models, clustering, code base, seismic demand, which is stuff that we will probably do. In particular, I'm thinking for the uncertainty on seismic models in the final part of the work that we are supposed to carry out. Earthquake scenario and seismic maps. So a variety of activities that, of course, will be of particularly interest for a variety of stakeholders, ranging from the scientific community to the reinsurance. On the communication and engagement of the public, the ways in which we thought this could be implemented is through the website, plus posts on social media. I think that so far, the posts on social media were done by Bruno and Innovacta. I think that maybe for the future we might think to help in contributing more and more once we will have more results available to disseminate. An electronic newsletter that I don't think at the moment has been implemented, but I'm happy to be corrected on that.
Sorry, Marco, the reference for everything is on all this part is Maria.
Yes.
It's Maria working on the social.
No, I know. And I've been indeed, as you might have seen at the beginning of my presentation, I've been contacting Maria and she gave me some feedback. And I don't know the extent to which, to be honest, I've been able to incorporate the feedback that she gave me, because I got her message on first day last week, and I was too busy with the preparation of everything. And I did my best, but I'm certainly not leveraging as much as I could have done with the work and the information that she shared with me.
No, don't worry. I think it's just it's really important that you show what we have in the project proposal. Yes, the date is a mistake, 2024.
Yeah,
but no problem about the deadlines, because we can ask the European Commission to change the deadlines, but we have to do everything we wrote in the proposal, because they paid us for this. So it's important to share also with the students, because we have to do all
Indeed,
these parts.
and I think we need a lot of help from the students.
Yeah, absolutely.
And I think it's also for them important to learn how to disseminate their results according to the different audience that is, let's say, in front of them. Because that's indeed the fundamental rule of communication, right? To change the way in which you are expressing concepts or results depending on the person or the group of persons with which you are interacting. So moving forward with this, again, a similar table to the previous one. This is more focused, as I said, on communication with the public. And there are a number of initiatives that ideally we'll need to coordinate with Maria. And that is concluding the initial part, which was very much focused on the proposal and what we are supposed to do regarding communication, dissemination, and exploitation. The second part instead is about communicating earthquake science. So it's more about the challenges that we have in communicating the results of our research to the public and the potential consequences that that activity can have. Okay, because of course, communicating science to the public is extremely important, but the implications that this has, depending on this discipline, depending on the sector, can be quite different. At the beginning of the call, when I was talking with Bruno and Francesco in Italian, indeed, I was saying that communicating science when you deal with earthquakes is not like communicating science when you are talking about a constellation of stars, because when you're talking about earthquakes, you are dealing with a day-by-day life of a lot of people. And so there are implications that are quite delicate and that it's important to take into account. And hopefully in the rest of the presentation, I will give you some examples that are clarifying that and explain the challenges implied. To start, I took a couple of phrases from a couple of papers of people that I know are actually quite good, or organizations that are quite good in dealing with communication of hazard and risk. One of them is Jan Stewart, who made a number of very interesting scientific documentaries on BBC. And in one of the papers that he wrote relatively recently, he's writing that few scientists have a training or experience of translating their science for lay public, and conveying complex risk information is especially difficult in circumstances where scientific issues are socially contested and politically charged, which is exactly what I was trying to explain to you earlier on. And at the same time, and this is instead something written in a document from FEMA, the Federal Emergency Management Institute, which is an organization based in US, and it's a sort of civil protection agency. They explain that a key factor in successful hazard reduction is a thorough understanding of how society, individuals, organizations, and governments understands the earthquake threat and what can be done about it, and what factors ultimately result in behavioral changes that reduce the vulnerability. Here there is, in my opinion, something that is not completely precise, because I don't think that hazard can be reduced. Instead, I would have written risk reduction. Okay, but leaving aside that, it's clear the fact that in the opinion of FEMA, in what is written in this report, you can develop the best hazard model, you can develop the best risk model, but if you are not able to convince the public that they need to take that information and use it in order to reduce their risk, the science that you will create will only to a certain extent be successful, particularly when there's a need to make sure that what you are producing is applied. So public outreach in earthquake science, and I split the communication in two parts. One that I called in peacetime, so when basically you are not in the middle of an earthquake sequence, and another one instead where there is need of communicating during the earthquake sequence, because the challenges and the messages that you need to convey in the two cases are quite different, and the challenges are also varying a lot. So one example of dissemination, or actually it would have been better to say communication in peacetime, is to explain, for example, the finding of a study that is identifying an active, so discovering a new active fault or providing new information that is changing substantially our understanding of the recurrence interval for large events occurring on that fault. And when this is communicated, for example, in journals, this can raise a lot of concerns in the population. I know, for example, of a case of the San Ramon fault in Santiago. So the scientists published a new paper in which they were changing substantially the interpretation of the behavior of that fault, raising considerably the hazard. And the consequence of that was that a lot of people got extremely scared, because the research has been also summarized in an article in a newspaper. And the consequence of that was that a lot of the buildings, a lot of the area that was along the fault has been gradually abandoned, and the price of the houses in that area got considerably reduced because of that. Another example is to illustrate the hazard results in subsequent versions of an hazard or a risk model, because the way, again, in which you communicate that can be perceived in a very different way by the public. So, for example, if you say that the change is 10%, or you say that the change is a 50% increase, but if you start from a very, very small value of hazard, even a 50% is actually not a big hazard. Okay. These are things that maybe in the scientific community are clearly understood without misunderstandings, but in the general public, the way in which you convey that message is extremely important and must be considered very carefully before disseminating it. And this is a cartoon that indeed is sort of reflecting the importance of the way in which the information then is understood by the general public. Other examples, during a sequence, in this case, there's often a challenge to say, explain what might happen when there is a sequence that did not show yet a large event. That's, for example, the situation in which the high-risk commission was in 2009 before the earthquake in L'Aquila. So there was a sequence of moderate magnitude events ongoing, and they've been asked to say, provide some guidance to the population. Then there was a big problem of communication there that you are probably well aware of. that caused a number of problems, but that was indeed the position in which that group of scientists was back in 2009. At the time, for example, without even an operational earthquake forecasting with which they could guide or consider a bit better which were the potential evolution of that sequence. Or otherwise, the second case, of course, is okay, after the occurrence of big event, to communicate the way in which you might have either a decay of the sequence of the possibility, of course, of experiencing additional large events. That's also an extremely challenging position, and therefore the communication that you do with the public must be well balanced between avoid to make people too concerned, but at the same time to make sure that you are not giving the impression that the risk after a big earthquake is immediately completely disappearing. So challenges in general that I see in both cases, the earthquake process is complex and the evolution of the earthquake sequences can only be forecasted probabilistically. Long aftershock sequences have a strong impact that is material and psychological on communities. And in some cases, there is a sort of demand of sending reassuring messages. But again, this is something that must be done in an extremely careful way because it might give the impression that risk is actually decreasing or is low, which might not be the case when you are in the middle of a sequence of earthquakes. Sharing scientific information with the public is challenging given the diverse levels of education and the varying confidence with scientific topics. The attention in the media is very high immediately in the aftermath of a large event and almost inexistent in peacetime, which is when you can actually implement the most effective countermeasures. So when you are in the middle of a sequence, there's very little that you can do in order to reduce the risk, because the only way through which we can reduce the risk, well, apart from telling people that maybe if you are 100% sure or 90% sure that there will be a large event, to tell them to abandon their buildings. Okay, but otherwise, the only effective way to make sure that you are reducing in an effective way the risk is to strengthen the building, make sure that you are designing the new buildings according to the building regulations. And this is something that you can clearly do only during peacetime. The earthquakes are, moreover, low frequency, high impact natural disasters. That means that in many cases, people are forgetting, okay, the risk to which they are exposed. A few years ago, I was in Kathmandu and they were explaining, for example, that in Kathmandu, since there is a big gap right now, apart from the earthquake that then came in 2015, but I was actually there before the 2015 earthquake, and the Nepalese engineers were explaining that while in the past they had structures made of timber that were to a certain extent earthquake resistant, because of the big gap, people forgot to build buildings according to the tradition, and they shifted to instead masonry buildings, okay, so to structures that were actually far less resistant because there was a low perception of the risk to which they were exposed. And for people, moreover, understanding the risk, the way in which we are traditionally defining that in the scientific community is difficult. And therefore, it's important to find ways to communicate that risk by providing, for example, comparisons with cases that are more easily understandable. For example, by comparing the possibility of having your building damaged with the probability of having your building damaged with the probability of having a car accident, say in the next 10 years. Okay, that's a way through which people can perceive in a better way the risk to which they might be exposed. And in this example, this is actually the result of a research it shows that when the mean perception of risk, when you are indeed providing some proxies, is more effective. So people are so the general public is more able to understand than the threat to which they are exposed. And related to that, and related in particular, as I was trying to explain in this slide, the way in which the risk is communicated, I ask you to go again to Menti and answer to an additional question that I have here. So here you have five cities have the following risk. And what I'm asking you to do is to rank their risk according to the various descriptions. So which is the city of this one that has the highest risk, and which one is the one with the lowest risk?
I did me too, sorry.
That's okay. Let's wait maybe 1 minute more. Oops. Okay. By the way, this is not something I created, but I'm going to the next slide. This is actually a questionnaire that was used by Enrique et al. In this, and you find details in this paper. So the 5 statements that I've been presenting to you are describing the same earthquake risk, okay, but phrased in a different way, okay, and so they use either a 500 years, 50 years, or annual time frame, and they describe the risk of fatalities in relation to either a population-based frequency or the probability of being killed. So, and if you read this publication, something I found interesting is that it says this study partially supports the finding of this other research that says that the ratio bias influences the risk judgment. In that, the statement with the highest frequency was rated more risky than statements that presented lower frequencies. And if we look at the results, and let's see if we actually, you answered in a similar way. to what was answered. So a city, in our case, the one with the highest is there is a 10% chance, which is indeed also the one that was ranked as the first in their research. Then the second is, in our case, an earthquake occurring once every 500 years, which is, in this case, it was the fifth one. So it's actually the results in our case are slightly different than the ones that Heinrich et al. Found in their research. But it's actually very interesting. I found extremely interesting to see how different indeed can be the perception of risk depending on the way in which it is phrased, which is making me think a lot in the way in which we are supposed to communicate. And at the end of the presentation, in case, of course, you are interested, I can give you the PDF of the slides and you can retrieve all those publications, because I don't do work on the way in which risk is communicated. So for this part, I've been relying for the most part on work that you find in the literature. So, and now I'm moving to some examples of communication of science in peacetime, just to explain the way in which I see things. Well, first of all, the flow that I see in terms of going from, this is not exactly an application in communication, but it's more on dissemination and maybe also exploitation, is to start from the seismic source and ground motion characterizations, which are the two main components of an hazard model. You calculate hazard, you calculate risk. The hazard and risk information can inform the policy making. The seismic hazard and risk can be used to update and to improve building code provisions. And seismic risk can also be used to inform the insurance sector. So these are the three main areas where I see, where I think our work can have an impact on different communities. Going back instead to the societal impact, in peacetime, something that I found very interesting is this paper that has been published in 2009 in this NBC Bay Area. So it's a website for the area of San Francisco. And the interesting thing here, well, maybe also a bit scaring. So this is a paper in which I was explaining that after the publication of the user-free model, okay, the user-free model forecasted an increase of, so implied an increase of the risk to which California is exposed because of potential for multi-fault ruptures, like, for example, Kaikoura. And the implication of that was that the rates, okay, from the California Earthquake Authority went up and went up quite a bit. So this is showing that how strong can be the impact of work that, of course, we approach from a purely scientific point of view, because, and indeed, I think we have all a very, very high consideration for user-free. But from a societal impact point of view, user-free had a very deep implication, deep consequences on the public, because what they had to face were increase in the rates for their insurances, because the calculated risk from user-free went up quite a bit. Another I think interesting research that you might want to consider was the one that has been done for communicating the results of the latest seismic hazard and risk at the European level. There is a paper of Dallo et al. Published on natural hazard and earthquake sciences. What I think is extremely interesting in that case is the attempt to characterize and customize the way in which the result is presented, depending on different categories of potential, let's say, stakeholders, starting from models and researchers to professional users. And here you see some examples, the scientific community, and the interested public and the media. So you might want to take a look at that and try to, let's say, read and understand the way in which they've been thinking to communicate and disseminate results for the different categories. For the earthquake sequences, one interesting research that I found was indeed done by a number of social psychologists, I think, during the Christchurch sequence back in 2010. So that sequence was composed by two main events, an initial 7.1 where the rupture was here, and a second earthquake of smaller magnitude, a 6.2, but just under the city. And you see that overall there's a gap of some months during which there have been seismicity ongoing, and it has been challenging indeed to maintain the communication with the public and keep them informed. And of course, it was quite challenging to communicate with the public, but after the earthquake, the 6.2 that occurred some months after. And one of the major findings in this work, they were explained that after a large earthquake, the geoscience agencies are delivering information to the public. And vying it all, we're actually recommending that the communication is not just carried out by scientists, but there is always an interaction with between scientists and scientists that are more dedicated to communicating communication in general, to communicating geoscience, because by working in pool, you can indeed convey a message that is more effective than the one that might come just from the scientists. And there is also a different need that came out from this research that was carried out on the public, on the people that were exposed to this sequence. So they found that, for example, during the initial part of the sequence, there is more need to focus on, indeed, advising on protective actions, psychological support, self-care strategies. And maybe in the following part, there is then gradually a growing interest more on the scientific aspects. But at the beginning, it's very important to focus on the more let's say, immediate needs that are coming from the public and the population exposed to that threat. Media coverage is also something that I found. So there's a paper of Deve et al. Published in 2019 in which they've been analyzing the media coverage during 2015 in different parts of the world regarding earthquakes. And what is interesting to find is that in the media in general, what they are publishing is the most, let's say, the most sensational part of the event. So they are interested in saying the magnitude, if there have been human losses, the material damage, rescue operations. And the attention of the media for earthquakes is decreasing very, very rapidly after the event. And this is a problem, of course, because as I was trying to explain to you earlier on, when you can communicate, when there is a possibility of communicating preventive measures, it's not in the immediate aftermath of an event, but you must do it mostly in peacetime. And in that interval of the, let's say, the earthquake process, the attention from the media is in general extremely low, disappointingly. This is just say graph that is showing to you that for the different categories of topics, let's say, collected that you find in the media, the most part is on the impact, so general impact, human impact, economical losses, a little bit on the hazard, a little bit on response, but as you can see, extremely little on reconstruction process, for example. And this is another way just to again show how quickly the attention is indeed decreasing throughout the process. So in days, the attention is high. Then when you go to months, 2 weeks, and 2 months, and of course 2 years, the attentions get extremely low within the media coverage. Something that is becoming, of course, more and more common is to use social media during the sequences. During the one in Kamarash in Turkey and Syria, recently I saw, for example, that there was an extremely large social media coverage. One that was particularly active was Judith Hubbard. Here is, for example, posting a tweet in which she's saying that a lot of people have been contacting her, asking for information that she was not able to answer, like, am I safe? Should I move away? How I can contribute I can continue to live here, knowing that an earthquake might strike. So people, especially during the sequence, are seeking for information that is helping to, say, cope with the immediate risk to which they are exposed at. And these are some of the tweets in which they were indeed asking, so how long will the aftershock continue in these regions? Is a high-intensity earthquake expected? Is the design of the buildings not according to the expected earthquake? So basically asking if their buildings are safe or not. So these are all questions to which you are exposed, where you are in the position of communicating and providing information to the public during a sequence. And in this paper, in which, by the way, Judith Hubbard is also a co-author, what they did in light of their experience during this sequence was to put together amongst different things that are summarized in that experience, a number of guiding principles for communicating during the sequences, especially through social media. I'm not going in detail throughout all of them, also because I see that it's getting particularly late, but you will find them here, and you will see that well, while it's interesting, there are also some concepts that are to a certain extent in contradiction. In some cases, they are saying, for example, that you shouldn't use uncertainty. You should be, and I think it's in the previous one, uncertainty contributes to anxiety. Okay, but at the same time, they are recommending to communicate uncertainty. Of course, they are not entirely in contradiction, but of course, this is a component that must be considered carefully. And I'm scrolling through them quickly and trying to move now to the final part of my presentation. So your last one is actually quite interesting, because it says that your message will at some point misunderstood or misinterpreted. So it's important to our best to avoid misunderstanding and to maintain to the extent possible scientific integrity. So last part is about the communication of uncertainty. And I'm particularly interested in this part because in seismic hazard, uncertainty is an extremely important component of the problem that we are facing. And so the earthquake process in general is affected by large uncertainty. It is important to make sure that it is duly characterized and communicated. In seismic hazard and also in seismic risk, but in general, in many studies that are dealing with uncertainty, the uncertainty is classified, as you know, in aleatory and epistemic uncertainty. And the way to discriminate between the two is to, let's say, define the epistemic uncertainties as the ones that in theory could be reduced with time, by getting more information, developing more advanced models. And instead, the aleatory ones are the ones that not necessarily there's a chance in the future to reduce them. I found a publication that is actually very interesting regarding the challenge of communicating uncertainty. And in this research, they were subdividing, let's say, different objects that are affected by uncertainty. For example, facts, or the fact that there will be climate change, for example, that the temperatures would raise, numbers, or that the temperature will go from an average temperature global of X to Y, and on scientific theories. And two levels of uncertainties, one that is direct, so the uncertainty about that fact, and indirect, which is about the quality of the underlying science that was used to define that uncertainty. Because clearly, if you are using science that is affected by large uncertainty, by consequence, you might also say that the uncertainty, the results that you are calculating are also affected by large variability. This is the scheme through which they are explaining a way to communicate uncertainty. So who's the subject to which you are communicating uncertainty, what uncertainty, in which form, to whom, and with what effect. Cognition, emotion, trust, behavior, and decision making, because that's also, of course, quite important to take into account. And again, as in the case of risk, in the communication of uncertainty, there are different ways of expressing uncertainty with a decreasing precision. So you can be extremely precise and for example, communicate uncertainty through a probability distribution, but on the opposite side, you can simply communicate uncertainty by explicitly denying that uncertainty is existing. Clearly, in that case, there's basically no uncertainty at all. In a subsequent study, still by the same group of authors, they've been actually checking if the way in which the uncertainty is perceived by the audience. And this, contrary to what we might think, actually, there is an appreciation in the public around the fact that when you are communicating a result, you are also associating with that a corresponding uncertainty. Of course, it's important to make sure that when you do that, you are communicating the uncertainty in an understandable way. Okay, we are approaching the end, and I have a few additional questions for you in the Mentimeter. We can go to them, and then we can close my presentation. This is just a repetition of the initial question. So let's see what we... Okay, so this is a comparison between what you answered before and what you are answering now. So it seems that there's a clearer understanding of regarding distinction between these three concepts. And if we go to the next one, so the importance in thread, which was, if I recall correctly, already extremely high, so that might actually not change much. Okay, I think that we are all agree that it's very important to make sure we communicate, disseminate, and exploit our work. And in last one, I think is regarding your PhD. Okay, we still didn't convince at least one person, 2 persons. Okay, I think we are done. I'm glad that
I think if you ask the same question at the end of the PhDs, I mean, the answer might be different. I think it's only, you know.
it's interesting that indeed, while for thread, for example, we had 100% basically, whereas in this case, there is still the perception that maybe communication is not so important. Communication dissemination, or maybe something that I didn't do that probably would, in retrospect, would have been interesting is to ask what's the weight that we give to communication, dissemination, and exploitation in thread and in the PhD, because clearly there might be, at least in some of the candidates, the feeling that maybe communication is more for the project and for the individual is more important to focus on dissemination and exploitation, which is the more, let's say, scientific focus component of these activities.
All right.
Okay, hope you find at least something useful. As I said, I will share the PDF in case you want to read any of the publications I mentioned there. And
I saw, I mean, I was, you know, amazed by one of the tweets, you know, on, you know, about, you know, website when, you know, the guy mentioned, you know, 7.4 occurring, you know, 7.4 occurring within, you know, 4 years of each other in the Middle Age. And, you know, saying that, you know, maybe we
yeah,
can
this one.
pick one again, like, you know, and.
Sorry, am I showing my screen? No, I'm not. Sorry,
no.
let me.
But
So,
apparently, like, I don't know.
this one.
Yeah, either, you know, the experts.
Yeah.
So, you know, even after L'Aquila, I don't know, you know, what these experts are, but I mean, they should be very careful.
Absolutely, absolutely.
I find it amazing, actually. But,
Yeah.
mm.
Yeah. And there must be very strict protocols. I'm actually sitting now in the same high-risk commission of okay, so I have that role right now, and indeed within the Italian civil protection now there are very strict protocols in the way in which communications is conveyed to the public, and I think that this is extremely important to avoid any misunderstanding and make sure that communication is done by people that know very well the way in which an information must be transferred to the public. Yeah.
Actually, yeah, I mean, I have a question, but not for you, Marco, but for the students. I mean, if they follow, like, you know, on Twitter or on, you know, other media, if they follow, you know, scientific, you know, communication, especially in earth science, I mean, because, I mean, that's something I don't do personally, but I mean, do they, I mean, you guys, I mean, do you actually follow what's going on in the research world, like, you know, in earth science? Can you say something about this?
In my case, yes.
Okay.
Usually, for instance, Alice Gabriel is really she publishes a lot, so usually follow her. Some of them are really famous, actually. Just in my case, yes.
Is it on Twitter or on X or like or blogs or?
Usually on Twitter and also on LinkedIn, actually. Yeah, it's really a lot of promotion of science.
I guess it's a very good tool, actually, you know, to get, you know, people interested by, you know, the science. But on the other end, I don't know what you think, but, you know, it can be dangerous too, because, you know, it's giving a lot of attraction on only a few people.
It is indeed, yeah. And also it can be time consuming depending on the amount of time you invest on it.
Yeah.
Okay, I need to sign out. I'm sorry, but I need to run now and catch a train in order to get back home.
No, thanks a lot, Mark. Just a very quick comment also for particularly for the students, because I think we will discuss also during the training school about these topics. We will have also the presence of Massimo Crescimbene, he's a psychologist working in INGV. But my request is to digest a bit all this stuff. Then please try to discuss all together when we will be in presence. I know that in presence is better, but it's really important for our project also this stuff that are not directly what we call research, but it's something that is requested not only from the European Commission, but from the society working on these topics. So I think it's really important. Let's think about this, and we will discuss in Sicily all together. And thanks a lot, Marco.
Thanks a lot, Marco, again. Yeah.
You're welcome. Cheers, everyone. Bye.
Thank you, Marco. Bye-bye.
Welcome. Bye.
So we will. Okay. So we'll. When is Sicily again? Yeah.
End of May.
End of May. Okay.
The last week of May.
So Menandrin's presentation is before that. Okay. So
Yeah, it's important to have these pieces before.
good. So see you guys in 2 weeks' time. In any case. Bye.
Thank you.
Bye-bye.
Right.